we are saying the coordinates of the vertices of a parallelogram are this, and this. We are asked to find the coordinate of D. Okay, let's first, we are going to use the Cartesian plane here. Let's draw the axis. Assuming this is my y-axis and this is my x-axis. So let's locate the vertices first. So the first one is 1. Okay, let's start with this. This is 1, 0. So x is, remember, this is origin. X is 1, y is 0, so it should be here. So this is 1, 0, and we know it's C. So the next one is 1, 9. So let's call here, because this is the same 1, 9. So it should be A here. 1, 9. So the other two, C is, okay, B is 2, 5. So 2, 5. So something like this. So 5 should be below 9. Okay. This is 2, 5. So we'll call it B. 2, 5. So the last vertex should be, okay. Okay, D as here. We don't know the coordinates, so let's join the
Okay,
this is our parallelogram, but we know that the one characteristic of a parallelogram that the diagonals intersect at the midpoint. So if this is the midpoint, the diagonal, assuming this is the diagonal, they must meet at the middle. So that's what the property we are going to use here. So let's call the coordinate of the middle to be M. So let's find this. Let's call it A, B. So remember from our coordinate geometry, the coordinate of the middle is always, I'm saying that A. The coordinate of the middle is always the sum of that's the average of the x coordinates. So we have 1 plus 1 over 2 and 9 plus 0 over 2. So I'm using A and C as the endpoint. Also for this, so let's call the one we are looking for x, y. So it must also be equal to x plus 2 over 2, y plus 5 over 2. So they are the same as far as this is the middle. Whatever that is here must be average of these coordinates. So we have 2 over 2 is 1. This is 9 over 2. Must be equal to x plus 2 over 2, y plus 5 over 2. So we'll compare. So we are saying that from here, which implies that 1 must be equal to x plus 2. Because this is x coordinate over 2, and 9 over 2 must be equal to y plus 5 over 2. So from here now, we have that x is 2 minus 2, 0, and y is 2, 2. So 9 minus 5 is 4. So the coordinate of what we are looking for is 0, 4. That's the coordinate of D. Our answer is B. Said ABC is a rhombus of side HCM if AC is 8 root 3. we have to find the measure of angle BCD. So first, let's draw the rhombus. So this is the rhombus. So they told us, let's name it this A, B, C, D. And they said AC is 8 root. So that this, they say this is 8 root 3. And of side, that's all the sides, remember, that are congruent, they are all 8. So they now ask us to find the measure of angle BCD. So we are looking for this. Okay, what we know about rhombus is that the vertex angle, that is whatever that is here, the vertex angle, that is the diagonal divides the vertex angle, that are equal. So if here is theta, here is theta, and also this is an isosceles triangle, so here is also theta. So we need to, once we know this, we've known theta. So again, as I'm seeing a special triangle here, this is 8 root 3. So 30, because there's what we call 30-30 triangle theorem. It says that in any triangle, okay, let me write this. 30-30 120 triangle theorem. So it states that in any triangle of such form, that if here is 120, this is 30, and this is 30, the ratio of the sides, that here the ones facing 30 is, if there are x each, so this one must be x root 3. So the ratio must be 1:1 root 3. And that's what I'm seeing here. This is 8 root 3. So the ratio is 1:1 root 3. So without waiting time, theta is 30 degrees. And this is 120. Therefore, the angle we are looking for, angle BCD, is just 30 degrees plus 30, which is 60. So that's the answer, 60 degrees.